All right, so at this point in the course, you've been taking a look at classes and abstract data types in your lectures, and we're gonna kind of modify and extend a program that we did earlier um, for programming exercise 18 by creating a polynomial class. All right, so an abstract data type that represents a polynomial, and this is a really classic use of classes because a polynomial is a real thing and it's got properties and it's got there's operations that you can do on it. So I'm going to have what we're going to do is create a new class that has three attributes representing the A, B, and C coefficients. And I'm going to implement a few different functions on it. First off, I want to implement evaluate. An evaluate function for a polynomial just takes a given value of x and returns whatever it is. So, depending on what a, b, and c is, if you plug in 2 as x, you're going to get a different value. And if it happens to be a root, it'll equal 0. But if it's not a root, it'll equal something else. So that function will just accept a single parameter. I'm also going to use the find roots function. I'm going to have the find roots that we used from exercise 18. In fact, I'll just copy that code in and modify it. And I think it's useful to see what's different about it when it becomes a method inside of a class rather than a standalone function. And then finally, I'd like to support the string method. Remember that's kind of like this magic method on a class that whenever Python wants to convert your class or your object into a string, it'll call. And so I'll build a string that represents a real nice printout. So I've given you sort of a sample program. I'm going to kind of do that, although I'm going to use assertions and actually develop sort of a test case instead. But it'll be pretty much similar. So I can start out over here. All right, so I've already pasted in this test case code. So I don't have this class yet, but I want it, and I'd like to be able to create instances of my polynomial using 3 parameters in the initializer. And then based on the values, and I've already kind of plugged in these values and figured out how many roots they're supposed to be. And these are examples from exercise 18. I'd like to call find roots on polynomial 1, and I expect it to come back and be 2, the length of that to be 2. I expect that the length of find roots on polynomial 2 should be 1, right? And that's because the discriminant was 0. 4ac, 4 times 2 times 2 is 16, b squared is 16. So the b squared minus 4ac was 0. And then P3, I had figured out earlier that had no roots, that had no rational roots. So the find root should be returned 0. These are exact same test cases from before, but now I'm calling them as a method. I'm also going to assert that the string P3, the string version of P3 looks like this. It looks exactly like that. And I'm also going to evaluate P3 by plugging in 5, and I know that I'll get 156 just by calculating 5 times 5 squared plus 5 times 5 plus 6. All right, so let's start by creating our polynomial. And in fact, I'm going to kind of work in reverse order. I don't want to keep throwing exceptions for things that I haven't developed yet. So let's just work on the evaluate. So polynomial and I know that I'm going to have an initialize function. Right? So this initialize function is what's getting called when I make this creation of that instance. Now remember that the all methods, including the init, are going to take an implicit first parameter. You don't have to call this self, but everybody does. So use that convention. It's not syntactically wrong if you call it something else, but it's probably a really bad idea. And then it also accepts 3 parameters, the A, B, and C. Now in that, all I'm going to do is I'm going to initialize some attributes. And remember to set an attribute on an object. And the object that we're talking about is self. We're setting an attribute on ourselves because we're initializing ourself. We are a polynomial. Self.a equals a. Self.b equals b. Self.c equals c. Okay, and now at this point my polynomial has those three attributes. So let's go and write the method for evaluate. Now the evaluate function, right, so I'm calling it right down here. Yes, it accepts one parameter, but remember there's an implicit self and x, right, whatever value I'm going to plug into this thing. And I'm going to return a squared times x plus b times x plus c. Right? So now if I run that, I made a pretty classic error, one that is pretty easy to make. And saying name A is not found, right? And again, inside my class, and I find that this is a mistake that you're probably more apt to make if you're coming from a different language, that you've already learned classes. If you've never learned classes, it might be kind of second nature, or at least the only way you've learned it, to always put self dot. But if you're coming from other languages, it's usually okay to use member variables just like this. So in Python, it is not. It doesn't have the rigid class structure that other languages do. So when we see this name A not defined, it's because, yeah, I don't have a variable called A. Self might have a variable called A. Right? And so I'm going to need to do that. In Python, we're going to need to be really strict in terms of how we reference member attributes like that. All right, so I run my program and lo and behold, nothing happens. And of course, that's because my assertion passed, right? If my assertion failed, let's say I forgot the C part, or actually, yeah, just right here. If I forgot the C part, my assertion would have failed. I didn't get 156, I got something else, I got 150. Right, so no news is good news in this case. All right, so let's work backwards. The string version of P3 should be 5 over 2, sorry, 5 times x squared plus 5x plus 6. Now if I run this, I'm going to get an assertion error. Certainly not. And by the way, it's useful to know what it actually is, right? So if I do a print of P3, Python's going to try to convert that into a string. That's what we get, and that's like the default implementation of converting an object to a string. It prints out what type of object it is. It's polynomial defined in your main file. It's an object, and this is the reference, the address that it's located in memory. Right, but I don't want that. That's not really what I'm after. All right, so let's create our function string. The only thing that'll accept is self. It's being implicitly called. Python's calling this function by itself. And I'm going to return a string that looks like this. Right? So I'm going to take string A, and append x raised to the 2, a string, plus string self dot b plus x. And I didn't really account for negative numbers here. You can go a little over and beyond if you want to try to practice. You can account for negative numbers so you can have subtractions instead of additions. It'd be kind of a good exercise for you to try. Okay, let's give this a shot. And I get to print out because I printed it out, but you can see exactly what it's coming out as, right? So that the presence of that underscore string function gets rid of this sort of ugly print statement and replaces it with what I built. And I could have put anything there, right? But this is what I was looking for. Let's take the print statement out just so it's just my assertions. All right, so the last ones, the find roots. So I'm going to go into example 18. I'm just going to pull out my find roots function because it's exactly what we're going to be doing. So this was a while back, and I'm going to add it to my class. Okay, but it's not really done yet, right? because this alone, this function, notice that I don't have self here. And I want to just give you an idea of what's going to happen, because this is an error that I make a lot too. Not necessarily because I copy code in, but I forget to put the self as the parameter. It says find root is missing two required positional arguments B and C. And it's hard to understand what that really means. And it's saying okay, well, what I'm calling it over here. Right. Well, first of all, I've implemented find roots such that A, B, and C is coming in as parameters, but that's not the way a member function really works, right? This member function or member method should be using selfs A, B, and C, right? Not some parameterized version. So first off, it's telling me, hey, you can't call find roots like this. But what's weird about it is it's saying it's required two. It's missing two required positional arguments, and it's interesting why that says that, right? Why isn't it three? I'm really missing three. I called it with no arguments. It's because the way the language works is that when you call a method to the right-hand side of some other variable with the dot operator, it automatically takes that variable and it plugs it in as the first parameter of the function. That's why this self thing works. All right. So anytime I make a function call on the right hand side of this dot operator, Python automatically takes whatever's on the left and plugs it in as the first parameter. So in fact, inside find roots, this has been called with one parameter, right? But that's snare because I need two additionals. That's not leading us really to the answer though. What we really need to change is the fact that this is a member method. So I'm going to take out those parameters. I'm just going to have self. But of course I have to actually go now and convert B, C, and A to self B, self A, self C, because otherwise I'm going to get name errors like I did before. Rather than write that twice, I'm just going to do this squared. Oops. And I'm just pasting in. D is not a self variable. It wouldn't make sense to be it. It's not a permanent variable. It's not a permanent attribute. It's just a discriminant. If you wanted to actually pre-compute it up here, you could do that, I guess. That could make some sense. All right, so every reference to A, B, or C, I think I got. I missed these. I think I got them. And I'm still doing the same job, right? I'm still returning an empty tuple if the discriminant's negative. I'm returning a tuple with a single value if the determinant is 0, and I'm returning a tuple of 2 if I've got two roots. So it looks like I was close. Oh, I got name math is not defined. Yeah, sure. So before we imported math, I forgot to do that. Right, the square root function. Okay, and no news, good news. Again, my assertion's all passed. That means my class is working as it was intended to work. So now I have a, if I'm involved in writing code that works with mathematics, later on we'll do things like plotting. We can probably plot this function. We can use this class as a reusable object and take advantage of it later on down the road.